Hello everyone and welcome. In this video I will connect my lawn mowers, Husqvarna lawn mowers, to my Magic Mirror. And I will be accessing the cloud service to get the status of my mowers and show it on the Magic Mirror. So I will be putting up the battery percentage and also the different messages from my two lawn mowers using the developer site and the developer APIs on the Husqvarna website. So welcome and hope you enjoy. So before we can connect to the APIs, we must make sure that our mower is set up to connect. And go to Accessories, and you want to go into the menu Auto Mower Connect. And then you want to make sure that it's enabled. No, it's enabled. Mower Connect is only available in not all models, so you need to make sure that it's enabled in your model and that you actually have that hardware because it can be optional. Now we should be able to connect. So the first thing we want to do is have a look at the APIs. And the APIs we will find on the developer site for Husqvarna. I will put the link in the description to that. And here you can click on the Get Started, and you will get the instructions to first of all set up an account. You need to create an account, and of course it needs to be the same account as you're using for your mowers, so they are connected to this developer account. And the next thing you need to do is to create an application. Here you will just give it a name. You will not need to put in a redirection URLs. It's only used if you have your own web page and so on. We don't need that. When you have created this application, you will get the application keys. Application key, application secret. And you need to make a note of this because this is what we're going to use when we start to authenticate. Authentication is a normal OAuth authentication type using client credentials and authorization code. And to find that documentation, we can click on APIs up here and click on Authentication API, and it will describe how you do the authentication. I will also show this later on. The next thing is to look at the APIs themselves. And we want to use the Auto Mower Connect API here. And if we click on View Documentation and Open API, we can see what kind of different calls we can make. You can see that you can retrieve different information about your mowers. You can also post actions, for example, starting and stopping your mower, set up schedules and so on. In my case, we will start with the first API here, just simple list of your mowers, and these lists are quite extensive, so they actually include all the information I will need. So I don't need to make any other calls. This will retrieve all the information I need about both my mowers. And if you want at this point, you can even try the APIs out here directly on this page. But I will be using Postman, and I will show you how to do that later on. You will also find information about how to set up WebSockets. I will go into that later on in the application. We will have a look at that. But now we are ready to start testing this out. So now we know what information we want and what APIs to use. And I like to start by testing this in Postman. Postman is a great tool. It's free for testing REST APIs, and I use it all the time. So the first thing I have done is that I set up a REST API call here. I'm using the get function, and I have filled in the URL to the API here. But before we can get any information, we need to set up the authorization. And the way that works is that we configure the UAuth settings. And I'm sure choose to use the client credential way. Give it a name. You select client credentials. You fill in the access token URL. This you get from the developer site. And then you fill in the client ID and client secret. And I believe this is called application key and application secret on the developer site. You fill in the scope. Usually it's OpenID. And then you also need to fill in an API key down here on the initial request. So this is actually the same as the client ID. So the application key goes down here as well. And it's important that you add it with a key like this, x-api-key. This information is on the developer site as well, but maybe not so clearly. So when we have this information in the correct place, we can tell Postman to get a new access token, and then we will use that token for as long as it lives to retrieve the information we want. So I click here and say proceed, and I say use token. So now it's stored in Postman. Now we can go back to our REST API call, and we can try it out. So you don't really need to fill in any other information. Most of this information is default from Postman. And I just hit send. And then we can see the result down here. Get the JSON structure back. That's the information about the mower, IDs, model, status, current activities, and all that useful information. It even has the position of the lawnmower. And if you have more than one mower, you will get all of them here listed. There are some other API calls that you can use, but typically this will give me the information I need. You can see it's 0% of battery right now. So I'm happy with this, seems to work. And the next thing will be to implement this into Python on the Raspberry Pi. So now we're ready to do some Python coding. And I do this on my Raspberry Pi. So Raspberry Pi 4, which is the running the code for the Magic Mirror. And if you haven't looked at my earlier videos, I suggest you go back and look at them first so you get a general idea of my setup here. But now we want to add communication to the mowers in Python. I'm using Visual Studio Code. I think it's the easiest way to code Python on the Raspberry. And the first thing I want to do is to add a file that I call Husqvarna. I will import that file as HQ. This is just a file where I have downloaded the different states and descriptions of the errors and so on. And you can find this on the developer website. So I've just compiled the information here, so it will be a bit nicer when I print it and use the information later on. So I load that. I will not use any other library. I will just use the HTTP request library, but no special library for Husqvarna. So let's have a look at the code. I prepared a class. here, and I will go through it and explain what I'm doing here. So the first part obviously is the variables that I will be using. We have the URL for the token to acquire the token for authentication. We have the actual URL for the API to get the mower information. And then we have also a URL for sending commands. I will not go through this in this video. And then we have a variable for the API key and also for the JSON authentication string. This is just examples here. I will set it to the real values later on. And then I have a couple of values to store my information. I will store it in different lists here. And that's what I need. Down here I have created a couple of functions. The first one is just a function that I will call once to initiate the lists. I have since I have two mowers, I've made this configurable for as many mowers as you have. So it will create a list with the size that is required. And I will have one list for the name, one for the battery status, one for the status, and one for arrows. This could, of course, be combined into a multi-array, but in my case, this was the way I did it, and just because it was simpler at the point of time. So let's have a look at the update function. The way I run this is that I will start it in a thread, which you will see later on, and then I will just run it all the time, and I will stop for the amount of time I want. In this case, 3,600 seconds is the poll time. So every 3,600 seconds, I will check the information. The call to start with is the authentication call. Here we use the authentication URL. It's a post call. We send the authentication JSON string. We send a header, which is basically just content type, as you see above here. And then we set the timeout, and then we want the response back in a JSON format. So when we send this, we will get back the ID, which is the token, the access token we will use for this session. And the next thing I will do here is to call for the actual data. So here is the URL for getting the data. It's a get call. I will use the authorization method with bearer, and here I will add my access token. And then I also need to remember to send authorization provider, should be Husqvarna, and I need to set this variable, as you remember from Postman, and this is set to the API key. So this is the complete call, and we will have a look at the response I will get. And then I will just store the variables into my lists. I will also modify the status because of depending on the state of the mower, I'm actually getting the status information from two different fields. Either it's mower state or mower activity. And that's just more for convenience. I could have two different variables, but this makes more sense for me. And then I will just wait for the poll time, and then I will retrieve some more information. So before we can start debugging this and showing you how it looks like, we will need to initiate the class. So we get down to the main in the Python. Then we have the initiation here. First, I create a class here, Husqvarna, and then I set the different URLs, and I set the credentials, the key and the authentication JSON. And this is just because I have stored my credentials in a special file. I don't really want to show it here. So I'm just getting that information from another Python file that I have. And here you can see that I set the mowers to 2, so it will read 2 mowers. And the last thing we need to do is that we need to start it and run it in a thread. And we have that information here. So first I will run the initiate. In this case, it's just creating the list for storing the values. And then I will run my Husqvarna update in a thread. So all of my different things that I'm checking in the Magic Mirror, they are run in different threads, but they have a while loop, so they will run continuously in that thread. And then we start the thread itself. So let's see how this works. So I set the breakpoint here when we go into the update function. Let's see what happens. The try here is just to make sure that we handle any exceptions. If the site is not available for some reason or something, then this will catch the exceptions and we can print the status down here. I will actually extend the poll time. If it fails, then I will wait for an hour before I try it again. So as you can see, I said the wrong thing last time. I'm actually polling every 600 seconds. So every 10 minutes I'm polling. So let's see what we get here. First is the authentication. We get the token back. So here we have the token. And then we call it again to get the result. And here is the result from the mower. You can see it's an array of 2 different mowers. And we get all the information we need here. So you can decide what you want to get from your response here. So in my case, I will just save a few things. I will go through it here and it will loop 2 times to store all the data. And then we can see that the array here with the names is just a simple array with a name. We have the status, we have the battery. Yeah, you get the idea. So let's let it run. So I forgot the most important thing. Before we can start, we need to have something to send back to the web page. So I have added the variables here that I want to send back to my Magic Mirror. It's a web page. And if you have seen my earlier videos, you know that I like to do a debug page as well. I call it index. And I will add all the information I have here on the index page as well. And now we can start it and take a look. So I executed directly from my Visual Code here. It's very convenient for debugging. So it's running again. Then we take a look at the page. It's a lot of information here. It's my debug setup. But down here, we can see that we have the status returned from my 2 mowers. And this is nice, I think. It's all the information I need. And especially if something goes wrong, it will give me the error message here and I can fix it. So this is really convenient. It's only showing if something is going on, For example, in the winter and so on, it's not showing, it's being hidden. And then I also have my index page. Take a look at that. You can see that I have the information I need here. Potentially I could put the whole JSON that is returned here, but this is more easy for me and more convenient for me because otherwise it will be very much information here. So I'm really happy with that. Okay, so I realized that updating every 10 minutes was maybe not so good idea. I want quicker response than that. And the API doesn't really allow me to update more often because of the restrictions on the Husqvarna endpoint. So I decided to use Websocket, even if I said I wouldn't. So let's have a look at the WebSockets then and how we can implement that and subscribe to events instead of polling them all the time. I will still be polling to get more information, but I think the events in the WebSockets are interesting and I want to use them. So we can look at the WebSocket APIs here. And what you want to have a look at are the different event types that you can get. Battery event, for example, if the battery charging changes. And you can see the payload here as well. And it's very simple JSON, it's just reporting the battery percentage. We probably also want to use the message event. And then we have the mower event, I think is the most interesting, where we will get back when something changes, status changes, the mode changes, the activity changes. So we want to implement this. And if you look at the other page here, it's quite easy to implement actually, and it gives you some directions on Python coding and so on. So we will implement this in my Magic Mirror now. So the first thing we need to do, I have already done this, but you need to install the WebSocket client libraries on your installation on your Raspberry or whatever you're using. And then we want to import this library for the to be able to use the WebSockets. Thread is something that I'm already using, so I will not be showing that here. So let's import the WebSockets. And then I will create a new function to run the WebSocket in, because when I start it, it will be running forever. So I want a separate thread. I will still have my thread to poll Husqvarna, this thread here. But I will add a new thread for the Husqvarna WebSocket. So let's have a look at the code. So the way it works is that I start the connection. I've added a while loop here just to make sure that the polling of the Husqvarna website has happened, because that's where I do the authentication. And when the authentication is done, it will hand over the token that I will use for the authorization. So that's why I have this part here. You could do the authorization directly here as well, but since I already have it, then I leave that. And then what we need to do is to start the actual WebSocket, and this is this part here. We have the URL that we got from the documentation, and then we need to have functions for the different things that can happen in the WebSocket. For example, when you open it, when you get the message, when you get an error, or when it closes. So this tells the WebSocket that call these functions whenever this happens. And then at the end we have the authorization with the JSON bearer and the token that we have. So that will initiate the WebSocket. And the last thing here is that we say let's run it forever. And you can also set up a ping interval. It's default to 60 seconds. And this will keep the session running so it doesn't terminate due to inactivity. And then if we move up a bit, then we have our functions here that we specified. And let's have a quick look at them. We have on message. We will take a deeper look at that. We have on error. So far, I'm just printing the error. I have on close. And what I actually do here is that if the connection is closed for some reason, I will just restart it. Let's see how that works. Maybe we need some error handling or something. But for now, I will just restart the connection if it's terminated. And on open is really just to get the print text to see that the connection has opened. Let's have a look at the on message then. So I begin with converting the message I get to JSON. So I will have the message in this variable, and then I will use that for retrieving the information. The first thing I need to check is for what mower it was actually reported. And I get this in a unique ID from the site. So I need to have that before. So I have saved that when I do the polling. I have saved the different long numbers that are the unique IDs for my mowers. So I can find it. And I'm storing the information in this dictionary here. So what happens then is that we get the message type here, and then we check it if it's a battery event, if it's a mower event, and right now I commented out the message event here. So now I will immediately update the battery percentage, or if it's a mower event, I will do basically the same as I do when I'm polling to retrieve the status of the mower. I'm checking the state and the activity, and depending on the state, I return that value. Then I also look up the error code here at the end. So I think this will work fine. Let's start and see what happens. So it's running, and I set the breakpoint on the start connection. And I have the token sent back. So we just run it. Now I directly get the message here. So let's see what that can be. It was actually empty, and that is because the first time where I start a connection, I get the message saying that it's ready. And in that message, there is no ID for the mower. So it terminated directly here in the loop. So, but I have a breakpoint here, so we'll wait for some communication from the mower. So here we get the message. Let's check that. We can see the message here. And it has an ID and it's a battery event. So step in here and then we can see I'm getting the battery percentage back, and it has updated my battery percentage. So that's nice. And let's run it. Get a new message here. We can see it's actually a mower event here. I triggered an activity on the mower. And it's picking up the information from the event. So that's really nice. So now let's let it run without any breakpoints. So it changed to charging here. So now it's charging. I will park it. So on my phone, I'm sending command now. Take some time to send it from the phone to park it. And there it's updated. At the same time it's updated on my phone, I can see it's parked. I can also see that the battery percentage is updated. So that's really nice. Basically instant feedback. Good. Happy with that. So while we have this running, we might as well test actions as well. So I have added a post action here. And I have the URL here, and in the middle I have my unique ID of the mower. So now I can post JSON in this format. In this case I will use start. And if we have a look at the start status right now, it's parked. And hopefully this will work together now and we'll get quick response. So I have Postman here. We send the start command. Like this. Sent. Take some time to refresh, and there it's actually charging now. So, but it accepted the start command, but it wants to finish the charging before it will start mowing. So it will probably change to mowing quite soon. And we can change it back here. We can say park and send that. So I will not have this in my magic mirror, so I will not actually implement this, but it's do it in the same way as everything else. You post it, create a JSON, send to it. There's one thing that is really a bit tricky that you need to know, and that is that the header is actually the content type needs to be changed. So you need to set the content type to this. So it can't be just application/JSON. You need to set it to application and this part here. That's really important because otherwise it will just not accept it. You can see here if I uncheck this, I will have the standard content type. If I do a send, I get a lot of messages here. Unsupported media type. So that's an important part if you want to implement that on your side.